Hey everyone, welcome back. I hope you are all doing fantastic. I'm doing well. I wanted to take a minute before we jumped into anything here and just thank you. I wanted to thank you for taking the time out of your day to spend with me to watch the videos. If you've been watching in order and you started from the beginning, we've been through a lot together. We've done quite a bit. And I wanted to dedicate a video to just discussing the topology change, which we're kind of looking at here. We've added a data center for our customer Cisco, or I should say for the customer Cisco in this example case. So up until now, we've just been kind of solely focused on, the sites themselves, interconnectivity in the site. And then we added the WAN connectivity between the two sites. Then we added the second customer. So that was kind of all geared towards WAN connectivity, site to site, all that kind of stuff. Now we're introducing a data center. So we've chosen Cisco to be the customer in this case with the data center. We're only introducing one data center for the moment. Maybe that changes down the road. Maybe we introduce a second one. All up in the air right now. But right now, I just want to kind of discuss what we see in the center here. I got rid of the second connection. There was a second internet connection coming from each site that we never configured, but it was there, left over. We've kind of converted the MPLS cloud into an internet cloud, whatever. It's neither here nor there. That's been removed. So the sites strictly just have the MPLS connection and an internet connection. That's all they have at the moment. What I did as far as the internet goes is I connected anybody that needs an internet handoff is going to connect to the iNet2 cloud here, okay? If they want to ping, like, let's say 8888 or 4.2.2.2, anything that's kind of a well-known internet address, I'm going to stick those here as loopbacks. And that way it's just a hop away. It gives us a chance to do another BGP peering. We can stick the loopbacks here. It's just kind of to add an extra hop. There's no real use case for it. I just wanted to kind of explain why that's there. But getting to the data center, so this is one way to approach a data center. There are several ways you can do this, okay? So what we're looking at here is everything above this horizontal line that's between the WAN firewalls. You can consider everything above this, or I should say above that line. So from the firewall up, it's going to be all public IP addressing, public facing, right? That's what we're going to call our internet edge or our public, network segment, okay? Below, so the WAN routers and below, so the two WAN routers, the Nexus 9K switches, this is a top of rack switch, and obviously there's some servers. All that stuff is going to be on the inside. So that'll all be private IP address schemes, which I've kind of laid out and defined here. So this particular data center, for the public autonomous system number, we're going to just pretend we're AS101, okay? So when we peer with the internet service provider, we'll be configuring BGP for ASN101, all right? For the WAN side of the house, so when we get these WAN routers configured and we peer with the service provider, we're going to be ASN 65001. All right, so there are the two ASN numbers we're going to be playing with inside the data center. For the public IP address space, we're going to pretend that we own a /24 public IP space, and we're going to own 101.1.0.0/24. So that'll be, 101.1, 0 all the way to 255 on that third, 101.1.0, and then everything on the last octet will essentially be 254 usable addresses or whatever it turns out to be. So the private address, that's what I was mixing up with the privates. The private address, we're going to basically have an entire /16 dedicated to data center 1. So that gives us all the VLANs that I have. Let me just zoom in. That way we can kind of, you're not straining your eyes. Should have zoomed in 2 minutes ago. So the VLANs, right, this data center will always be 10.101.something, okay? And then all the usable IPs will essentially reside in that last octet, kind of like what we've been doing this whole time with the /24s, okay? So I just wanted to kind of lay that out to kind of paint the picture. We're not going to be configuring all those VLANs. We're just going to choose a couple, and we'll stick these servers in those VLANs, and we'll do some connectivity tests. But I just want to kind of demonstrate the design aspect of things and how you need to really strongly consider how many devices does this data center need to support, right? Like, what's your workload look like? You got to be thinking about circuit size. All those factors come into play when you're discussing data center design. So what we're going to do is these DC1 Edge 01 and DC1 Edge 02, these are edge switches, or switches that I call them edge switches. They're switches that you can plug internet connectivity into. And you might ask yourself, well, why would you do that? Why wouldn't you plug your connectivity into, the firewall or the router or whatever? You can do that. That is a perfectly acceptable design. The use case here is if you plug your internet handoffs in. So if you look at Internet to Cloud, there's this 1.1 and it connects to 1.4 on the switch. And there's 1.2 and it connects to 1.4 on the other switch. Those would be, your physical IP connection handoffs. So service provider A, service provider B, whatever, you can plug those connections into a switch. Those switches will just get an access VLAN assigned to that port. So that's irrelevant to the service provider, right? Like, they don't care about the VLAN that you're plugging into. As long as the devices that need to communicate are on that same VLAN, everything's fine. So that's what we're going to do. And it gives you flexibility, because if we ever wanted to add a device to the data center later on, like let's say we're doing a firewall refresh, let's say we add a DMVPN WAN router, which is something that we may actually do, right? And it needs internet access. All you need to do is plug a port off that device into the edge switches, right? And you can stick it in that same VLAN, and voila, you have internet access through your ASN or through your public space. So that's an option to consider when you're doing data center design. There's two of them, so there's two edge switches, and these are actually Nexus 9Ks. Okay, same as the cores. They're gonna be the same exact flavor of Nexus OS, and we're doing that so we can take advantage of virtual port channels. And it's nice to be able to have redundancy. So one common theme that you see here is there's two of everything. The firewall is actually, let me just speak about the firewall real quick. It's depicted as a firewall. This is actually just going to be the same type of layer 3 iOS device that we're running for the routers. I just changed the icon to kind of present it like a firewall. This is where the firewall would sit. This could be a Cisco Firepower device. This could be a FortiGate firewall. This could be a Palo Alto. Whatever firewalls you like to deploy or play with, it could sit here. It would be an HA pair, so there would be two of them. You'd have either active-active or active standby. So the entire network stack from top to bottom will have two of everything. Okay. And that's so the data center doesn't go down. You want to try to keep that resiliency up and guarantee the 5 nines, right? This is also going to be where the NAT boundary is. So this is that separation between public and private. So we'll introduce NAT just like we did at our branch sites, just to kind of simulate that, make it a bit more realistic. There's 2 WAN routers as well. So again, they'll peer with the service provider. I peered one with the Edge 1, and I paired the other with Edge 2, so we'll be able to do some route target, imports and stuff like that, so that'll be fun. We've already seen it, so we can kind of whiz through that, if you will. The core switches are going to be, again, they're 9Ks, all right? We're going to be taking advantage of, again, first hop redundancy protocols. These are going to have interface VLANs. They're going to have a bunch of features that you'll see we'll have to activate and turn on with the Nexus operating system. So that'll be a change that we introduce here, as opposed to iOS XE or iOS. You have to turn on the features on Nexus platform. So we'll go through all that together. The top of rack switch, I wanted to just demonstrate what one top of rack switch would look like, okay? This is where design flexibility, again, comes into the picture. So depending on what you're doing, you might have 2 switches in every rack. You might have a single switch in every rack. But if you wanted to get redundancy all the way down to your server level, you'd have to introduce 2 switches in the place of this top of rack. It would become 2 switches, which are a VPC peer, very similar to what we've got here. And then your servers would have, NIC teaming or something like that. So they would connect one NIC to top of rack switch 1. They'd connect their other NIC to top of rack switch 2. And that way you have that hardware redundancy, right? So I'm not doing that here because at some point we have to shrink it down to a single point of failure. It's just inevitable. But, I just wanted to kind of talk through that. I'm hoping that I can do another series dedicated to VXLAN, which is going to kind of enhance what we're discussing here tenfold. Like this is kind of I don't want to call it a dated way to do it. It's tried and true, but there are newer flavors of data center design out there. ACI, VXLAN, they're kind of like the heavy hitters these days because it provides even more benefits than what we're discussing here. So we'll get more into that as we go along. The other thing that this could, you could consider this to be is the boundary between the virtual environment and the physical environment. And what I mean by that is, these servers could technically be virtual machines. This could be the handoffs to, let's say, like Cisco Fabric interconnects, which then take the flows over to Cisco UCS, which is the virtualization platforms, right? So all we're going to be doing here is essentially making this port a trunk port and this port a trunk port so that we can extend our VLANs into whatever environment that is, virtual, top rack switches, whatever it may be, okay? So the principles stay the same. It's just, if it's like software platforms running, like ACI is very software heavy, stuff like that. So all things you got to consider. I think that's all I wanted to just kind of call out. So we've got a lot to do here. We've got a lot to bite off and try to digest. So we're going to go through it together. We're going to take small steps and we're going to configure pieces at a time, verify connectivity as we go. And we're going to take this, what looks like a complex task, and we're going to break it down into simple steps, and we're going to get through it together. We may face, some adversity throughout the course. That's fine. We want it. We accept that. So, we'll conquer it. We'll get through it together. So I look forward to seeing you guys on the next video, and we'll start to dive into all of these devices, and we'll see what we can accomplish. So thank you again. Take care, and I will see you on the next one.